Welcome back, everybody, to this the latest part of today's session. My name is Jeremias Sulam. I'm an assistant professor at Johns Hopkins University, and I will be moderating the panel. But before we get to the panel, it's my great pleasure to introduce Professor Eric Xing, the president of Mohammed bin Zayed University of Artificial Intelligence, to give some introductory remarks. Professor Eric Xing.
Well, thank you for the introduction. I actually wasn't prepared for anything yet, and I just came back to Abu Dhabi this morning, so 12 hours ago I was on a flight here. So what should I say? Of course, welcome to Abu Dhabi. I'm very excited to see many colleagues coming back or coming here for the first time to discuss research. So MBZUAI, maybe I can say a few words about this university. It is a new university, maybe at least new to many of you. It was founded about 2.5 years ago in Abu Dhabi with a goal of kind of a seeding advanced research and the development of artificial intelligence in this region. And UAE is, as you know, a very energetic and young country that has a very, very aggressive and ambitious national strategy of bringing the country to the world stage as a new power of new technology and also economical impacts and serving their citizens and people. AI was recognized as one of the pillars of the country's next few decades of developments. And in that context, this university was created to be a hub for research excellence and also to be a catalyst of the R&D ecosystem and the technology transfer ecosystem for the region, and maybe even going beyond the country of UAE itself. So I was very privileged to be selected as the first president of the university. As many of you know, before I came here, I was a professor of computer science at Carnegie Mellon. I've been doing research in several areas, but in particular, probabilistic graphical models and machine learning and assistance, and some applications in NLP, in computational biology, and in computer vision. So when I came here, my goal is to really do what I'm good at, which is to continue my research with a bigger group of colleagues and students. So that's exactly how the university was started. It was very, very purely driven by a ambition of doing good research, to also promote the culture of doing good research, not only in terms of good publication, but also in terms of a good taste, and also good problems to work on. In the past 2 years, as you all know, it's very difficult for the entire world that we are in a pandemic. Travels are restricted, and also there are very interesting international geopolitical dynamics all over the place, and also there are economical turmoils in many places. In some sense, the country of UAE and the city of Abu Dhabi is a safe haven, for a relatively peaceful and tranquil research environment to thrive. So I personally took advantage of that opportunity. I worked with many colleagues. Some of them are here, but many of them are still on their winter break. We started from a very modest body of initial seeds, which I believe, I remember, has maybe roughly 10 faculty. That's where we began with, and no students. But in the past 2 years, we've grown to about 50, I think 48 or 49 professors, which are officially affiliated with us, and plus a couple of dozen affiliated adjunct faculty. And then we also have 3 classes of graduate students already. The first class will be graduating in a couple of weeks. And the quality of the students are on the rise. And for example, in the current incoming cohort, we've got a pretty significant percentage of students, I think at least 20 something, coming from top 100 institutions worldwide. So they are coming here to do master's degree in computer science or PhD. So we're very excited, to be able to attract top students from all over the world, to work with our professors on interesting problems. Maybe I can also brag about some of the numbers, right? So maybe one thing that made me most proud of is the caliber of our faculty. In the past year, at least 4 of our faculties were on the program chairmanship of top conferences, such as ACL, such as ICML, and UAI, CLEAR, which is a new conference in causal inference, and then myself co-chaired with Nizar from NYU Abu Dhabi as the local chair of EMNLP. We actually brought the conference to Abu Dhabi. Again, all this is really meant to promote, high quality research activities and presence, in the region. So in a sense, when people, we are in a small audience, hopefully this word stay in the world, right? So usually when we look at a young university in a young country, there are naturally many questions, right? Oh yeah, what's the future of the school and why they do this? Do they do this for hype or for fame or for whatever? I'm aware about all these perceptions. People, come to a new place with all sorts of uncertainty and question marks, about what to expect. So what we are trying to do at MBZUAI is to make it, starting from day one, a very, very authentic and simple and also very energetic research organization that is focusing on promoting research excellence. So hopefully, the past 3 days of workshop give you kind of a flavor of what our university is emphasizing. This workshop is one of the 6 to 7 workshops in a cluster program called AI Quorum, which is again our unique idea that is meant to invite leading researchers and also active young researchers and students to come for a very focused and energetic and maybe even how should I say heated conversation focusing on research itself. And we are trying to provide some breathing room for researchers to be able to focus on science in addition to having time to relax, but not to be kind of distracted or entangled with big venues, with tight deadlines and terrible review processes and so forth. We are ourselves researchers. We actually understand what we are facing as a challenge in our community. So we're trying to do something a little bit more creative and also as a new alternative, for our researchers to find new excitements and maybe new opportunities. And obviously, we are very actively also looking for people to join our course. So if any of you, especially your students, want to, for example, spend some time as a visitor or even to join an organization, definitely let me know. I'd be very, very happy, to continue the conversation and to hopefully find something exciting, for our guests to spend more time here. So with that, I think as I've said enough for the university and for the city. In fact, I encourage you to take some time off to really look around. January and February are the best season of Abu Dhabi. I admit there's something less desirable of Abu Dhabi, which is the very hot summer. You don't want to come here in July or August, for tourism. You can still, stay in the room for research. For tourism, it's a little bit challenging. But now it is actually the best season. I encourage you to go to the beach, go to the desert, and talk to the people here. There are a lot of, interesting activities. People here are very friendly. They all speak very fluent English. So communication and life here actually are quite easy. I personally find it just as easy, if not more easy than my life in Pittsburgh. So I totally thoroughly enjoyed living here and working here. And I'm sure that you will feel the same. Okay, in that, I'm returning my, my microphone to the organizer. And
Thank you so much. Take the middle seat. Thank you so much, Professor Eric Xing. So it's my great pleasure to now welcome the rest of the panelists that will be joining us for the afternoon discussion. So if I could invite, please, Professor Yima from UC Berkeley, Professor Gita Coutinho from LMU, Jason Lee from Princeton, and Professor René Vidal from UPenn. Terrific. By the way, I'm really thrilled and honored to be moderating this and be sharing this discussion with such a selected group of panelists. So I will begin by asking a few questions, and I will in particular direct these questions to some of you to direct the conversation. But if you want to comment on someone else's question, please by all means feel free to answer as well. And I should also stress that it was hard to pick a subset of the attendees here to be part of the panel. And so there's many people who are not sitting on stage who could nonetheless contribute very much to the conversation. So if you would like to comment or ask a question, you can also do so. Okay, so to get started, I would like to ask Jason and Eric a question. And this has to do with the observation that in hindsight, it's easy now to see that really access to massive amounts of data and computational power was key in getting machine learning where it is today from where it was, let's say, in the 2000s. Now, we are basically at the 10-year mark since the 2012 ImageNet competition that sort of marked a before and an after. And so 10 years in, I'm curious what your opinion is on whether more data and more computations will eventually enable a new paradigm for machine learning, or whether there is a bottleneck somewhere else. There's a microphone right there, and there's another one here.
Okay, I tend to think that probably most of the progress will be driven by just more data, more compute, with some small innovations like we've seen transformers have since really changed things. Maybe ResNets can be something else in the last 10 years that were a big deal. So I kind of think that probably next 10, 15 years, all the progress, or 90% of the progress, say, will be from just scaling up our architectures and letting them process more data.
Interesting. Eric?
Yeah, I have maybe even within myself, a pretty contested view. On the one hand, I do agree that data will ever increase with our additional, ever increasing device and the hardware and infrastructure. They will all generate more data, but I don't think that is the only source of advancements or innovation. If you look at the evolution of other science, so biology, physics, chemistry, yeah, data increase played a role. Like the celestial data leads to the discovery of the Newton's law and the gravitational law, and the data of the spectrum, allow the physicist to also develop, say, the atomic physics theory and so forth. But there are many other, advancements, such as the discovery of the general theory of relativity, the discovery of the standard model, of physics, are not driven by data. It's actually driven by the accumulation, of theory and experience and so on, reaching to a point that they start to be conflicting, or they start to be, confusing or redundant. In fact, the Maxwell's equation was also a phenomenon of that, right? So there is then a need of either a reduction, or in a transformation that seeks a deeper insight, and these are not data-driven. You can say that these are nature science, and scientists, have their unique way of approaching their topic. But I think even in the field of AI, if I were to design an AI agent, I would actually follow the wisdom of those great scientists and look beyond data and look into the opportunity of actually trying to work on additional dimensions, of the problem, right? We all see, for example, right now, ChatGPT and some of the foundational models, are able to do certain things, but you all see that people are able to trick them, to mislead them on very different things. Well, one way is that maybe this is just because of shortage of data. I'm going to add more data. But recently, I read even an article, which many of you probably heard about. It's about model as an agent, something like that, right? Your data is, fundamentally having inconsistency because it's coming from different people. It's generated by different sources. And there are something fundamentally not answerable by data because there are intrinsic inconsistencies in the data. You have to basically stage out of data to, discover or abstract additional laws and the rules or maybe experiences, which hopefully can come back to curate data or to even refute certain data or to override them. Right? So I see the future of AI research to be such a cross-fertilizing dynamics where data plays one role, but on the other hand, you are cognizant about something going beyond the data, and also there are wisdoms from past knowledge that you want to actively integrate into the building of the model that can be used to digest data. So in a sense, the opportunity is bigger than just data.
I think I fully agree. It seems that there are these periods of developing models of computation, and then a period that follows where we apply these models massively and we collect a lot of data, but eventually we need to revise our preconceptions of these models and then go back to the drawing board and eventually, hopefully, move the process forward. Would you agree with that statement?
Are you asking me?
Yes.
Oh, yeah. You said it well. Yeah.
Okay.
I mean.
Terrific. Okay, so I want to move on to the topic of the role of applied mathematics in the development of machine learning theory and methods. So I perhaps want to ask in particular Professor Gita and René, as both of you and many in this room know, applied mathematics was really instrumental through the 90s and the early 2000s in developing analytical models for real-world data. And these models were not just theoretical, they enabled the development of very efficient technological tools. For example, JPEG and JPEG 2000 would have not been possible without the contributions of harmonic analysis, and they continue to this day to be very useful tools. So now that we are in a world where a lot of these engineering solutions are mostly data-driven, what do you think is the role for analytical models of data in machine learning?
Yeah, thanks a lot for the question. So from my viewpoint, I think one should look much more at analytical models because they have a huge advantage. So for instance, think of imaging sciences. If you have an analytic model of your data, you immediately treat all different resolution levels basically at the same time. Also, if you model your data in an analytic way, I mean, you have much richer mathematical tools available. For instance, you have the whole function analysis available to prove your results, to understand your algorithm in depth. So let me give you two examples also from my research. For instance, in imaging sciences, computed tomography, limited angle computed tomography. There we also considered analytical models, and then we could use tools for microlocal analysis, for instance, to derive very precise prior information for then using certain reconstruction strategies using these prior informations for regularization. And this would have not been possible if we would have just viewed the image, let's say, as a matrix. Only there, I mean, we could use those tools, and then certainly you can also involve, like Jeremias said, methods like wavelets, shearlets, where we know, and we have these powerful results that we know that we can sparsify data, we can incorporate that. But then also, as I said, I mean, the second point is that you have a lot of, let's say, mathematics available in the background. So for instance, there we have results, if you, for instance, consider graph convolutional neural networks, I mean, then what you can do, for instance, for analyzing generalization abilities of those, you can build a continuous space on top of those and then view graphs as a discretization and then use these continuous and analytic models basically to understand how generalization abilities happen. So in that sense, I mean, from my viewpoint, I mean, one should look much more, and so I would encourage everyone also to take that into account, that then we have a much richer mathematical theory, and also it is often much more adapted to the data. And then maybe one last point, if you think of this whole area of partial differential equations, which is used to model basically any technological phenomena worldwide. These are typically, I mean, if you look at numerical analysis of PDEs, these are always analytic models. And so right now also AI has a tremendous impact on this area. So people use for the high dimensional regime now AI-based solvers. And so there you have classically analytical models. And so in that sense, people working in that direction consider that in a very natural manner.
Renee, any comments on that note?
Yes. I think throughout the history of science, there's been always an alternation of theory versus experimentation in different domains. If we think about maybe the discovery of F equals to ma, I guess the joke is because the apple fell on the head of Newton. What about Maxwell equations? Did we do all of the experiments first, or did he derive the equations first? What about maybe information theory, where communication systems developed before Shannon's definitions of communication or after? I think there are several examples where you therefore have theory that has resulted in very impactful technology. But I think there is also many examples where experiments have driven the development of new theory. When it comes to artificial intelligence, I think there's been examples, like the one you gave about compression, where solid mathematical theories led to very powerful compression techniques. But I think when it comes to other problems in AI, computer vision being one of them, the development of, say, generative models for vision has a 50-year history. And it was very hard to get them to work. And it's only recently, due to the influence of data-driven methods, that we have very powerful and more successful generative models. So I don't see this as a fight between theory and experiments, but rather as an iterative process where theory drives new methods that are principled and more generalizable, and experiments leads to new theoretical discoveries. And I think it's better to think about both of them in an integrated fashion, because otherwise you develop theories that don't have any impact, or you do experiments that have no foundations.
This is wonderful. I'm very happy that you bring up this push and pull between theory and practice, because this is a question that I was thinking about earlier this morning. I really can't help myself in asking you all. Many people in this room obviously are interested in coming up and understanding theoretical models for the phenomena that we see around deep learning. Now, like you were saying, in physics, a strong aspect of a good theory is that the theory should be falsifiable. In other words, it should be able to produce predictions about observations that, if it were untrue, it would enable us to disprove the theory and make progress and move on to something else. So obviously, naturally, we don't know what those things will be for a given theory. But if I ask you, what do you think those predictions of a theory about deep learning would look like? What would you like being predicted that could then be verified empirically for deep learning theories? And perhaps Professor Ima could try to take a shot at this question.
Well, so I like you to mention that also all theories are falsifiable, right? Because they're driven by trying to explain observations, and they're all not perfect, but they actually become very useful if they're good enough. Which sort of suggests that that's actually, even the whole scientific process is a learning process. Is the community is learning about the universe, physics, biology, or all the sciences. So that actually comes back to also what kind of theory, right, we want for machine learning, or even natural intelligence or artificial intelligence. Okay, maybe that is a characteristic for all learning, the individual or the society, right? And hence, I think any learning process needs to have those elements that we learn a model, then we test it against observations, and we try to predict. And we correct our errors in the process, right? Hence, it's not just a one-shot optimization or learn a model from a fixed set of data. It's actually continuously evolving. The learning system needs to have that mechanism, right? Have the same characteristic as how science progress through history, or individual learn things through lifetime, and so on. So those are the things I think we need to have a theory to be able to, a framework to be able to capture the essence of that process. I'm actually personally also in the quest for such a framework or paradigm. What's behind? What makes learning efficient, right? So just to little bit echo with the first question you asked, right? We're building very big models driven by data. I mean, this is very inductive. And this is actually a great value, as Renee pointed out, right? And experimental physics actually driven, it has to play a great role to drive the theory, discovery of physics. But don't forget, right, in the history of the mankind, there are at least two fundamental methodologies. One is inductive, one is deductive, right? So since Euclid, geometry and the foundation of mathematics actually from very purely deductive, starting from very clear assumptions, right? That's equally powerful. Just like, example of special relativity and also Maxwell equations, actually it is a very kind of unifying and deductive thinking, actually further driving the frontiers of practice. I think those are the things, those are the two pillars of how to push our understanding of even intelligence or anything moving forward. I think we need to have elements of both. In particularly, I mean, in the past 10 years, we've been doing a lot of empirical research and characterized as inductive approach. We made a tremendous progress. But I want to conclude with one analogy, right? Yes, we have discovered things. The engineering of big models with big data computing has, generating systems with great performance. But that's sort of like we figure out how to make airplanes. Boeing can make bigger and bigger airplanes. It is very useful. You can make a lot of money. It's very, very useful. We can continue to make airplane bigger. But but you cannot learn how birds fly by following how Boeing make bigger and bigger airplanes, right? There are other problems, probably more exciting, about the intelligence, right? How nature works and so on, which will have additional, more exciting things to discover. And we need to do that more, yeah.
Yes, completely. And this goes back to this healthy conversation between theory and practice that you were referring to before. Yes, please.
Actually, I like both of the questions asked and want to make some small points here.
Of course.
To the previous question about the value of theory, if I were to put it down, very simply, I think the theory that, in any science, but in particular our science are working on, need to deliver the following three dimensions of values. Why is that? Theory, is beautiful. In fact, just pursuing a theory out of data and finding the law and discovering the pattern, is an intellectually rewarding kind of experiment and exercise that gives you, a simple and beautiful view of the world. I think you can do theory only for that. I think it's totally fine. But the second value of theory, which probably is even more exciting, is that it actually makes things actionable. You cannot basically just carry a brain that remembers everything without being able to do reasoning. And that's usually not actionable because once that person is dead, that piece of knowledge is gone. But if he can summarize everything into a theory and write a book, the knowledge carries. I think the same thing, for the theories that we work on, from data or even total abstractly, from experiences, it allows, systems and machineries, to be produced to carry out functions. I think that's a very, very interesting view about the theory. The third one actually is probably less emphasized, but now I'm doing my job as a university administrator. I also see a value, which is just keep your brain alive and agile. Why we do sports? Are we trying to run faster than a horse or what? But still we have all these sports games. It's to keep our body active and functioning. If you don't do theory, you start only counting on a calculator or a library or a memory to remember everything, your brain will dead after a while, right? So we need to even do this for the sake of keeping our brain functioning. So that's how I see the value of theoretical work, either dependent on data or independent of data, to be still valuable in any academic or human society. Now, coming to your second question about what kind of prediction that could be desirable these days in addition to what is already offered. I do see a lack of tension right now in the theory of the theory, which is, for example, an uncertainty quantification. When you make predictions, what is the theory about the quality of that prediction and how to quantify their uncertainty, right? And also conformal theories, like how can you understand how many experiments you'd have to do to reach to a satisfactory level of guarantees and so forth. I think nowadays, in many of our applied work, there are some theories already there, but it is still focusing purely on prediction of the next move or of the extrapolation of a pattern, but not yet onto the level of qualifying those predictions themselves or qualifying the practice of the experimentation, right? So this is where I do want to see some additional effort, maybe from the theoretical domain to help us kind of broadening our study.
I really, really like the analogy of exercising and working in theory. But to your last point that you were making, I wonder if an avenue to do a better job at creating and developing theory for example, uncertainty quantification, among other topics, would potentially be benchmarks. If there's something that the machine learning and computer vision community have done relatively well is center efforts around benchmarks and competitions or definition of tasks and metrics. And so I wonder if one could, for example, have a benchmark for a certain analytical theory or rule to predict certain properties. And some of that has started to appear in, for example, NeurIPS and other venues. I'm curious what you think of that.
It's a very interesting question, and I always have a strong opinion on these questions, but I don't mind sharing that with you, right? So computer science and AI is one of these few areas where the word benchmarks or leaderboard are very, very, frequently mentioned. I came out of a physics background, and I also studied biology. In those fields, people are not talking very often about benchmarks or leaderboards. You are discovering a truth, or you are studying a phenomenon. You're not in a rivalry or competition, to beat others and so forth, right? So I would downplay, in a sense, the role of a benchmark, in driving the science. If we need benchmarks to drive the science, it's a little bit unfortunate, honestly, because for truly, a profound, scientific study, it's just like when we sometimes resort to something less rational. We say, you'll find it, when you see it, right? Sometimes, if we are setting our goal high enough, it's about really, understanding a fundamental phenomenon or implementing a fundamentally challenging function. You will get it, when you actually, work long and hard enough. This is less relevant than whether you clear a leaderboard, because the benchmarks, I don't deny their role, like ImageNet, and others, is really important, in driving the field forward. But they can drive you only forward that far, rather than all the way down to the ultimate goal, right? So I think we have already enough emphasis on that. That's why I don't want to add any more word into that. It's already enough. I would rather kind of advocate the non-benchmark, purely curiosity-driven or function-driven kind of work instead of the benchmarks.
Yes, absolutely. Please, if you want to follow up.
Yeah, so I would like to add one comment. So I completely agree with what was just said. So let's think back to imaging sciences. I mean, there we had a lot of benchmarks, like, for instance, denoising the LINA image. So what was produced were a lot of denoising images which were specifically tailored to denoise a specific image. And this is, I think, what we don't want in science. So we would like to have some comprehensive theory. And so benchmarks, as said, can drive us further, but they drive us to a very specific direction, and so this might blind us from other problems.
That's also a very good example that me personally touches me in particular, because I've also worked in image denoising, and one does feel whether one is really pursuing the right goal at working every single time with the same subset of images. Okay, so I want to move slightly to foundational models, which were mentioned before. If I could share my screen, please. And so I wanted to ask you a question about foundational models and language models. But one of the wonders of doing research today is that we actually have direct access to these tools. So I'm going to first ask the same question instead of to you, to GPT-3. So what I want to know is, what are the implications of GPT for scientific writing? I don't know. Should we be worried? Okay, I'll let you read along. You can also track the, I'll read it for you. So GPT, short for Generative Pre-training Transformer, is a type of language model developed by OpenAI that is able to generate human-like text based on a given prompt. While GPT has the potential to be a useful tool for generating drafts of scientific papers and other written documents, it is important to note that it is not capable of performing original research or generating new scientific insights. Therefore, the use of GPT for scientific writing should not be a cause for concern. It is important for scientists to carefully review and verify the accuracy and validity of any information generated by GPT or any other automated tool before including it in their work. Ultimately, the responsibility for the quality and integrity of scientific research lies with the human researchers who design and conduct the studies and interpret these results. So, now that we are all more or less convinced that these tools are indeed extremely powerful, and also with the context that 2 or 3 days ago, ICML released the guidelines for the new submissions now at the end of January, and they strictly mentioned that they prohibit the use of GPT or any other language model to write and contribute to scientific papers whenever it's not the object of study. I'm very curious to know your impressions as to what are really the implications of these new tools in the way that we produce and in the way that we validate and evaluate scientific knowledge. Please.
I'm not worried at all, right? So I think I also see a Twitter from Yana Kuhn says that, well, if you find this is a language corrected by small model or medium-sized model would consider, or even just spelling, right, at some point. So I'm not worried at all because, you know, I write books, okay? So, but for many days, you know, we are all in the intense scientific discovery, right? I read papers with Renee or with books with Renee, but we don't know how it works, right? Renee is a great writer, but I don't trust what he writes, right? I mean, he can put pages of description, but it's the content that matters, the substance that matters, the logic, the presentation that go way beyond just some kind of natural language, right? Renee is a master of the English language, but not necessarily I would like what he wrote about a certain presentation of the chapter. I probably have to rewrite it. Then I have a hard time to convince him what I wrote may be good enough for him, right? I think that's the process. I think certainly the chat box lacks the ability, right? How to organize, you know, much deeper substances and the reasoning and the presentation. I worry more about that. But of course, if you settle for very, very mediocre writings, and then that's probably, you should worry, right? People could put a lot of, you know, gibberish on the internet. But I'm more interested in the future, you know, that if machine can help us with that kind of level of writing. Right? For now, I'm not worried. Actually, I find it may be helpful. You know, it can, you know, save me a little bit, you know, just like auto spelling, right? If I make mistakes, typos can help me and give me some suggestions. But ultimately, I think as a human being, we're far more superior in terms of master how we want to present something. I think in terms of chatbots, I don't think it's that level. Yeah.
Thank you. Professor Ching.
I want to pose a exactly opposite view, just for the fun of debate. I'm very, very worried. Yeah, the reason being the following, right? Yeah, so we are at you know, a certain level of scientific capability. We write papers and so forth, but we live in a society with a few billion people, you know, which could get information from us, but also could get information from elsewhere, and we have no control of that. And I worry that if the content generated from you know, generative models become the dominant source of information in our society, that to the point, say 99% of the content are coming from GPT-3, and you don't actually know it, then what our children would read, and how can you actually make your work standing out to even catch attention? That's actually what I worry most. This is like, you know, in the good old days, you know, I use the example of, you know, pesticides and chemical fertilizers. You know, yeah, you know, we know that we have, you know, organic productions and thousands of years of agricultural practices. But once this cheap stuff come to the play and you don't regulate it, eventually just become pervasive, and then they stay in the soil. The truth is that they stay there. You cannot get rid of that. So for the GPT contents and for all these contents, right now, do we even have a way to prevent them from entering our universe of literature and reading? Right. So that's something I'm deeply worried. I worry that in 10 years, when my children, you know, grow up and study, they cannot find authentic book from the old classical literatures and from true scientific authors, because they were just inundated by the artificial contents, that is in the internet. Because you remember, when we build search engine, we basically are building the search engine from the totality of the text that is available from your crawler. And if your crawler end up crawling all this stuff without being even informed, then you type and you will just get all this at the top of your list, and you cannot even bail yourself out of it. That's what I worry most. So I'm not worried about me writing an article, and making sure that it is authentic. I'm worried about the entire ecosystem being fundamentally changed by the kind of this infestation or the over kind of abundance of artificial contents. It's never happened in the past in the human history. In fact, that you have such a very, very low cost or even free generator of contents and without regulation. So it's a new phenomenon I think our policymakers, our civilization need to deal with to really, it's like a drug, right? It's very cheap, it gives you happiness. They would stay there if you don't do something. And here I kind of feel such a risk emerging that we may not able to see any authentic human writing when the opposite become the dominant material in the universe.
So I personally share some of your concerns, and I wonder, going back to your question or your comment as to how, as a community, should we even prevent this from spreading? I think that we are at an interesting point where, even though these models are sort of broadly accessible through a browser, physically they're still relatively concentrated, and they are so expensive to develop, logistically and otherwise, that the number of entities and people that can really host these systems and develop them is relatively small. So I wonder if that is perhaps an upside, and whether that will enable us to get these tools perhaps under the needed control before they become ubiquitous. But I believe Renee wanted to make a comment.
Yeah, I think I share Eric's concerns. I think I have mixed feelings. I think there are cases where this could be incredibly useful and cases where it could be incredibly harmful. I think it's a great help to improve your writing. I think if we had had that when Yi and I were writing the book would have been written in half of the time because I would have just taken Yi's chapters and passed them through GPT. But I mean, I'm looking at my little kids who are now being able to do their homeworks and just potentially submit text, and all kids will submit. I mean, we were discussing in dinner yesterday that you can just begin with a text, actually begin with a written text from someone else, pass it through tool 1, pass it through tool 2, pass it to tool 3, and eventually produce a new text that more or less says the same thing. And therefore, the ability to be creative and to really know the content begins to be debatable. I am not concerned as much as of today regarding research and the ability to do original research. But who knows, right? This is what it's today, what it might be within 10 years. And I'm part also of the leadership of the computer vision community, and we did have the debate as to whether this should be banned. And there was very diverse opinions. But primarily the question is, how are you going to check if the text is original or not, and if the ideas are original or not? When we can detect plagiarism today, it's really the tool is very bad. It's really just checking word by word whether it's the same text. But now that the text is generated, there is no way to check whether you can plagiarize the text of someone else. That is very dangerous, but how are you going to check? We don't have systems to now detect that. So I think there are, like with any new technology, there are many potential advantages and many very good uses out of this. In particular, when it comes to writing what you write much better. But there could be many dangers. And what is the right way to regulate? We might debate, but even if we debate, like banning the use of it, we can't enforce it.
Yes, please.
Yeah, and maybe also one additional point. So I really share the concerns which were raised. So for instance, we have large-scale conferences where we submit papers, they are reviewed. Now, if some of these journal articles or of these articles are written in an automatic way, maybe in a very nice way, so then sometimes the reviewers might be just impressed by the writing. And so this is something which we cannot prevent. And as René said, I mean, we cannot basically check whether these articles were written by such an algorithm. And so people who have access to these methods, who are very knowledgeable, then can maybe write articles who are much more impressive than others who have maybe much more scientific content. And so that then it depends very much on the reviewer panel, whether they are able to really dig into the paper and extract the scientific content, or whether they are just impressed by the type of writing. And so this, I think, also I see as an additional concern.
Do you think that these concerns that you all voice extend to other domains beyond NLP? Because the evolution of generative modeling has been drastic, not just in natural language processing, but also, for example, for certain classes of images. Nowadays, the images of people that can be produced synthetically are extremely compelling and convincing. Likewise, generation of computer-assisted art, if you want to call it that way, is also getting a lot of popularity and in fact, you know, an increasing part of the market. So I wonder if you think that these concerns and these questions that we have about the use of these technologies in NLP will inevitably extend to other forms of data as we keep improving our generative models.
Yeah, what if we type generate a video of Yima stealing a book from the library? Right. Eventually, we're going to be able to generate videos and evidence for anything we want. How do we check whether it was true or not?
Suddenly came up with a crazy idea, just want to throw to the pod, right? If you look at the beauty of Snapchat is that, you know, they exist for a certain life cycle and they just disappear, you know, based on, you know, the production rule. Every digital content, in theory, had a code or can be placed a code, you know, based on their hardware, where they generate, or based on their transmission pathway and so forth, right? So in a sense, digital content is traceable if you want to trace it, and also is enforceable, you know, if you enforce it. If, you know, there is regulation that for every piece of digital content, image or text or other things, you know, that you produce, you need to kind of implant a barcode in it. Then, you know, it's up to the regulator choice. You can ban it, you can let go it, or you can restrict a life cycle that it has to exist only for like 30 hours and so forth. That might be, at least technically, I think that it's not that terrible. Technically, this is less dangerous than, you know, a biological virus or a chemical compound once produced, hard to undo. Digital products, actually, it's not that easy to undo if you want to undo it. So in a sense, you know, there is a way for the regulators and legislators or the policymakers to be a little bit more proactive, you know, on that. Just a crazy idea to share here.
Yes, absolutely.
But on that point, more broadly as to the ethical implications of AI, I think it's not up to us, the scientists, to decide on what the right regulations are, but rather to provide the trade-offs to the regulators for them to decide where to operate. The only cases where we play a role is in deciding whether these tools are used for our own scientific publications. But for all others, implications in society, I think the regulators and policymakers should have the ability to set policy according to a broad spectrum of possibilities that our algorithms should provide.
Okay, as we come close to the end, we have a few minutes left. I would like to share the fun that I'm having talking and discussing with all of you, with all of the audience here. So I would love to open the room for questions. So if you would like to ask questions to the panel, please go ahead. Yes, Sai.
I was reflecting when you were speaking about things moving in a direction where we are just competing against benchmarks, and there's like a half a dB improvement in image denoising on Lena, and then people are super excited as though that's the greatest thing that ever happened. And we've been through those phases. And so instead of having these incremental goals, like immediate goals, it makes much more sense to have sort of a longer-term vision of what we are trying to aim for with AI, and then work towards those kind of longer-term goals or visions and dreams or whatever you would like to call them. So my question to the panel is, like, what do you envision in kind of a more longer-term, the big challenges we can aim for as researchers from within this community, that are fundamental problems that we envision AI can solve sort of in the longer term?
Any takers?
I think there are many ways to answer that question, so let me begin with one. I think at the origins of AI in the 1950s, the goal was to be able to develop machines that can reason in the way we humans reason. Have we succeeded at that? Okay, there was the example of GPT, but in computer vision, right, we can today detect objects, relationships. We can maybe solve some basic visual question answering problems. But we are still very far, very, very far from even what a baby can do. So I think, to me, at least in computer vision, the grand challenge remains the same that was still in the 1950s, which is just the ability to build a machine that can reason with images in the same way we humans do. And I think, to me, that will remain the grand challenge, despite all the progress we've made, because I think we continue to be very, very far from that.
Any other questions from the audience? There's a question over there. Oh, do you want to make a follow-up comment? I think it's on. Should be on.
Okay, yeah. I can add to Renee about the potential grand challenges. Yeah, so there has been a set of grand challenges which is fundamental in AI in terms of the cognitive goal and the very definition of the I part, or the AI part. Do visual reasoning, do natural NLP, NLP reasoning and so forth. I actually do encourage us, the community, to think even beyond that, to see AI as a tool. If AI as a tool, there are actually a lot to be done, in terms of grand challenge. For example, what AI is very good at is exactly that ability to distill data, to gain insight, and now we are trying to position it, to do, language production and image production, which actually human beings are very good at already. But human beings are not very good at many other things which AI could step in and try to enhance and augment. For example, recently I've got excited in doing AI for drug design. Many people are working on these topics, right? What people are very good at is this very long process of sifting from billions, trillions of compounds, and all the way down into one drug, that can pass, clinical trials. And this whole pipeline of complexity actually is a big data problem. You have just too many options and too noisy data, for you to sift through and get an insight. And that's where actually AI could, be positioned modest enough to be a tool for the biologists and for the pharmacologists to actually, do in silico experimentation, to do, perturbation outcome prediction, to do structure prediction. That's what AlphaFold was very successfully doing, right? You could now solve, a 1-year-old kind of a 1-year-long problem into a 1-day kind of a computing effort. So here, I cannot even enumerate how many grand challenges exist just in the space of understanding life, developing precision medicine, and do lifestyle management and all that. That's one direction. I think that's a lot more interesting, exciting than producing fancy image and fancy videos and all that. Another topic I want to share with you is, again, a topic that is at the heart of the leadership in the UAE, which is the environmental kind of implications. I just came back from Austria, this morning, right? For the whole week I stay in the Alps, there's no ski, or no snow. Okay, it's just so warm weather. And of course, we can debate on the science, what causes that. Maybe it's the solar activity, or maybe the human activity. That's not maybe the key issue. But at least we understand, our human activity, our energy, practice, and maybe our own AI, computing has a environmental footprint. How can you actually, ask the right question to help reducing that? Either by helping other industry sectors to control and optimize, emission, and so on, or maybe to cut down the computing cost of training a GPT to 1/10 of its current consumption. These are actually very, very important and interesting technical questions. In fact, they are very technical. They are probably even more technical than many of the, tackling of the big model problems that I see people are playing with. But we don't see too many people are working on those, right? So there are a lot of opportunities I think could be presented to our community beyond just content generation, or prompting, or leaderboard and the benchmark clearance, of a certain, performance scores. Just add to what Renee just mentioned.
Gita, did you want to make a comment?
Maybe let me add one last point. Can you hear me?
Yes.
Okay, sorry. So one last point I would like to raise is also a larger perspective, which is embodied AI, so robotics. Because we need their AI, so reasoning, but we need much more than that. We need to combine it optimally with natural language processing, computer vision, and so on. So all of these areas there have to play together optimally. And also the robot has to do, let's say, lifelong learning and so on. So the challenges to AI are there tremendous. And as said, I mean, it comes together with a lot of different other disciplines, like natural language processing and so on. So I think this is one ultimate goal which one should aim for.
I'd like to maybe pose a little bit of a grand challenge that is closer to this community that is more focused on the theory of deep learning. So I think it was 2015 when Stefano Soato, Guillermo Sapiro, and I organized probably the first tutorial on the math of deep learning in Chile in 2015. And I think the progress in the last 7 years on the theory side has been quite remarkable, and we have a lot of significantly better understanding today than we had 7 years ago. But I think I'm hard-pressed to find at one instance where the theoretical development we've done in the last 7 years has impacted practice. By and large, we've been trying to understand phenomena we observe in practice, and we have done so by making simplifications and abstractions and conclusions about very simplified models, but that has not fed back into improving practice. So I would advocate that one grand challenge has to be to aspire to have some theoretical framework that really impacts the practice. Perhaps one might be architecture design.
One last question over there, perhaps? Oh,
I
sorry,
can
please,
just add to this a little bit what Renee just saying. I think that's absolutely true. I mean, that's also, since as a, theory has to be useful, especially if you want to develop a theory that has impact, right? Another thing is that there has been a lot of good understanding progress in the past many years, understanding probably a certain aspect of the, deep networks or systems and so on. But I actually think that the grand challenge to especially any intelligence system or learning system, it's actually facing us as a theoretician or even as engineering is actually integration, right? Intelligence systems are very complicated systems. They're not just one single factor playing. It's usually several things together, right? Optimization, control, error correction, and so on and so forth. They actually work together. But we don't have framework addressing those things collectively, right? In science, we like to say, divide and conquer. But I think we're at a stage we need to unite and build. Intelligence system is a complicated system that contains multiple factors, right? We should stop writing paper about something is all you need, but also if something is not enough. Several things work together, right? So put all the puzzles together. And that's a theory we're reading, that's a framework we're short of. I really think that's a grand challenge at, very at a technical level, right? Especially for the more theoretical or computational foundational community. That's a grand challenge we need to address in the coming 5 to 10 years, right? To have such a framework that really serve practice, guide practice, lead practice, right? Yeah.
Thank you so much. So a fortunate but also unfortunate event is that all these discussions have been so interesting that we ran out of time for more questions. So if you have more questions, I would encourage you to talk with the panelists afterwards. So please join me in thanking all of you for fantastic comments and insights. I personally enjoyed it a lot. Thank you so much. And with this, we will conclude today's session and resume tomorrow morning for the final day of the workshop.